ever just stop and wonder what's really going on inside your body, like right this very moment? Well, we're going to take a super quick tour of your own anatomy. And we're starting at the top with the most complex, most powerful part of you. So, what is going on inside your head? It sounds like a simple question, right? But the answer, well, it's anything but. That's not empty space up there. Nope. It's the source of every single thought, every feeling, every action you've ever had. So yeah, let's take a closer look. And there it is, the command center for your entire body. We're going to explore your anatomy from the inside out, and we're starting right here with this absolutely incredible machine, your brain. Okay, so let's get our bearings. First thing to know, the brain isn't just one big gray lump. Not at all. It's actually a collection of super specialized parts, all working together like a perfectly tuned orchestra. Now this part here, this is probably what you picture when someone says brain, right? That big, wrinkly outer layer, that's the cerebrum. And it's basically the hub of your consciousness, your thoughts, your personality, pretty much everything that makes you, you. So how do all these different pieces fit together? Well, you've got the cerebrum, which we just saw. That's the thinking part. Then, tucked underneath, you have the cerebellum. It's in charge of movement and balance. The corpus callosum, think of it like a data superhighway, a super fast connection, letting the two halves of your brain talk to each other. And then there's the brainstem. That's your body's autopilot, handling all the stuff you never have to think about, like breathing. And we can zoom in even more on that cerebrum. Up here at the front is the frontal lobe. Think of it as your brain's CEO. Then on the sides, you've got the parietal lobes, which handle senses like touch and temperature. And way back here is the occipital lobe. That's where your brain processes everything you see. And what connects all this to the rest of your body? The brainstem, which itself is made of 3 parts: the midbrain, the pons, and the medulla. Okay, so you've got this incredibly important kind of soft organ running the whole show. You'd expect it to have some pretty serious protection, right? Well, it absolutely does. The skull is just a masterpiece of natural engineering. And here it is. This is not just some bone helmet. No way. This is your brain's custom-fit, high-impact armor. Every single curve, every ridge, it's all designed for one thing: maximum protection. Now, you might think your skull is just one solid piece of bone, but it's not. It's actually more like a really complex, high-tech jigsaw puzzle, and the pieces are all fused together at these special joints called sutures, which don't move. Let's get a closer look at one of those sutures. See those jagged, interlocking lines? That's the lambdoid suture right there. It's this jigsaw puzzle design that makes the skull so incredibly strong, because it spreads out the force from any kind of impact. Okay, now if you look at the bottom of the skull, you'll see this really big opening. It's called the foramen magnum, which is just Latin for great hole. Pretty simple name, right? But its job is absolutely critical. This is the exit ramp where your brain connects to your spinal cord, which then sends messages to, the rest of your body. All right, so we've got the command center, the brain, and its armor, the skull. But what about all the parts that let us actually move and, show what we're thinking and feeling? For that, we need to dive into the dynamic world of muscles. Just look at this. Your face is covered in this incredible, complex web of muscles. The one circling your eye, that's the orbicularis oculi. It lets you blink and squint. And this one here, the zygomaticus, that's the muscle you can thank for every single smile. It's this amazing network that literally translates feelings into facial expressions. Okay, let's move down from the face to the torso, to our core. You can really see the layers here. You've got the famous rectus abdominis, that's your six-pack, running right down the middle. And on the sides, you have the internal and external obliques. All together, they create this powerful, flexible wall that supports your entire trunk and lets you move. So far, we've been looking at the big picture stuff, right? The macro level. But to really get how all this works, we've got to change our scale. We need to zoom in, like way, way in. So let's take a long bone, for example, like the femur in your thigh. It might look pretty simple from the outside, but inside, it's a total hive of activity. You've got different kinds of bone tissue, marrow, blood vessels, the whole shebang. This is going to be our doorway into the microscopic world. All right, time for a quick pop quiz. That tough outer covering of the bone, what's it called? That would be the periosteum. And it's super important because it's the layer that has all the nerves and blood vessels that keep the bone nourished and alive.
Okay, next question. What about the hollow shaft? The main part of that long bone. What's that called?
That's the diaphysis, and the hollow space inside it is called the medullary cavity. That's where you'll find all the bone marrow. Okay, now let's zoom in on the muscles. It turns out not all muscle tissue is the same. You've actually got 3 types. First, there's skeletal muscle. That's the voluntary stuff you decide to move, like when you pick something up. Then there's cardiac muscle, which is only in your heart, and it just beats on its own, thank goodness. And finally, there's smooth muscle, which works inside your organs without you even thinking about it. So 3 totally different designs for 3 very different jobs. So the big question is, how does a muscle actually move? The answer is this little thing right here, the sarcomere. The best way to think of these is as millions and millions of tiny little engines. You've got these filaments of protein that slide past each other, which pulls the whole muscle shorter and creates a contraction. Literally every single movement you make is powered by these microscopic engines all firing together. I mean, it's just incredible when you stop and think about it, right? We started in the command center of the brain, looking at these big, complex lobes, and now we're all the way down to the tiny protein filaments inside a single muscle cell. It's just a beautiful, perfectly integrated system of engineering. And believe it or not, we've barely even scratched the surface. As you're sitting here right now, there are countless other systems working silently, perfectly, just to keep you alive. So it makes you wonder, what other hidden incredible machines are humming away inside you at this very moment?